Welcome to homework.
So we have a cyanogen gas where we fluorine gas to produce carbon tetrafluoride and also nitrogen trifluoride gas. What will be the mass of carbon tetrafluoride that is going to form if we use 60 grams of each reactant? Okay, so first of all, we have to balance the chemical reaction. Here's the first thing that we have to do. So in order to balance the chemical reaction, we have to make sure they have the same number of carbons. So we have two carbon and also two nitrogen. So I put a 2 in front of CF2, CF4, and two NF3, MF3. Okay, so we have the carbon and nitrogen balance. The last thing we're going to balance will be the fluorine gas. So from here, we have two of the carbon tetrafluoride, so we have 8 fluorine gas, and then we have 6 fluorine gas from the NF3. So we have 6 plus 8, we have 14 fluorine atom, 14 fluorine atom. So we have to put a 7 in front of fluorine gas in order to balance. We have a single amount of fluorine atom. Okay, so the next step again, we are going to convert the reactant mass to number of moles. So we have carbon plus our nitrogen, and we have both of them. So we have 60 grams divided by the molar mass of the cyanogen, and we should be able to find it as 1.15 moles. Okay, for fluorine, we will have 60 grams divided by fluorine. We have 2 fluorines. So it will be equals to 1.58 moles. All right. So just do a quick check again, at 1.58 mole. Okay, so the next step is we have to find the limiting reagent because we are given the amount of each of the reagents, then one of it may be in excess, one of it may be not. Okay, so when we say if we want to completely react with all the cyanogen CN2, I mean the whole CN2, what would be the fluorine that we need? Okay, so you can see that the molar ratio is 1 to 7 from cyanogen to fluorine because the coefficient is 1. The coefficient of fluorine is 7. So we're going to multiply the number of moles of our cyanogen, and this would be the number of moles of fluorine that we need. And you can see that we need 8.05, way more than that of the fluorine that we have. So therefore, fluorine will be the limiting reagent. All right. So by using the number mole of fluorine, you can find the number mole of carbon tetrachloride. Okay. So the molar ratio is 7 to 2. 7 to 2, you can simplify the ratio. 7 to 2, you can divide the whole ratio by the smallest number. We have 3.5 to 1. 3.5 to 1. So therefore, you want to find the number of moles of our carbon tetrafluoride. We just need to take the number of moles of our fluorine divided by 3.5. So 1.5 divided by 3.5, we will have 0.451 mole of carbon tetrafluoride. So we just convert that to the mass, and then we will have the answers. So we have 0.451 times the carbons will be 12, plus we have 4 fluorine, and then we should have 39.7 gram of carbon tetrafluoride.